Hello students, let us discuss group 15 element reactivity with oxygen. The elements of group 15 combine with oxygen directly or indirectly to form two types of oxide, that is E2O3 and E2O5. E2O3 are called as trioxides and E2O5 are called as pentoxide. Let us compare the acidic character of some oxides of nitrogen. The oxidation state of nitrogen in these compound are in this way, that is +1 oxidation state in N2O, +2 in NO, +3 in N2O3, +4 in N2O4 and +5 in N2O5. So when we compare the acidic character in these, the acidic character increases with the increase in the oxidation number. Since from +1 to +5, there is increase in the oxidation number, therefore the acidic character increases. So we can say that the oxides in the higher oxidation state of the elements are more acidic than the oxides of the lower oxidation state. But when we compare the acidic character of oxides of group 15 element, that is acidic character decreases down the group. That means when we compare the acidic character in the trioxides of nitrogen, phosphorus, arsenic, antimony, bismuth, it is observed that the nitrogen trioxide and phosphorus trioxide, they are strongly acidic, and the trioxide of arsenic and antimony is amphoteric, and the trioxide of bismuth is weakly basic. So what it shows that the acidic character decreases down the group. As we have already discussed, top to bottom, metallic character is increases. That means the basic character is increasing down the group. Basic character increases means acidic character is decreasing. So since here bismuth is a metallic, so it show basic character. So we can say that the acidic character decreases down the group. So the oxide in the higher oxidation state of the element is more acidic than that of lower oxidation state, and their acidic character decreases down the group. The oxides of type E2O3 of nitrogen and phosphorus are purely acidic because nitrogen and phosphorus are non-metal, but top to bottom metallic character is increasing. Therefore, the trioxide of bismuth is purely a weakly basic. Let us discuss the structure for the oxides of nitrogen, that is nitrous oxide. The structure is given here. The two resonating structure is given here. Nitric oxide, the structure is given. Since in this odd electron is present, you can see the odd electron is present here. So this is does not follow the octet rule. Next, structure of N2O3, that is called as dinitrogen trioxide. In this, the oxidation state of nitrogen is +3. The structure is given here. For nitrogen dioxide, the structure is given. Here also there is one odd electron. So it does not follow the octet rule. It makes dimers. It dimerizes. Next, dinitrogen tetroxide, where the oxidation state of nitrogen here is +4. Its structure is given here. Next, dinitrogen pentoxide, the resonating structures are given here. Now how we can make the structure for these oxides of nitrogen very easily? Let us discuss this one. First of all, make the Lewis structure for NO2 that we have already discussed in the previous classes. This is the resonating structure for NO2. Since in this there is one odd electron on the nitrogen, it does not follow the octet rule. So it dimerizes. Now, how will we making the dimer for this? Make one more structure in the opposite way, in such a way that when here, look at the structure, nitrogen have a single odd electron here, and in the structure also nitrogen have a single odd electron. That is given here, this is and this. Now what you need to do? How to dimerize this one? Make a bond between this. Now this is the structure for N2O4. So just now we have discussed that this is the structure for NO2. When you make one more NO2, but write it in this reverse order, keep a bond between them. Now the structure of N2O4 is ready from NO2. It's very easy to make the structure for N2O4. Now let us make the structure for N2O3. For this, one of the single bonded O need to remove. Look at the structure carefully. I'm removing one of the oxygen in this way and keep two dots on the nitrogen from where you have removed the oxygen. Now this is the structure for N2O3. So just now we have discussed the structure for N2O4. From this, one oxygen is removed, so we got N2O3. So we learned three structures, that is the structure for NO2. When we dimerize, it gives N2O4. When we remove one oxygen, we'll be getting N2O3. Now how to make the structure for that is the structure for N2O5. Just now we have discussed the structure for N2O4. Here look at the structure carefully. There is a single bond between the two nitrogen. Look at the structure carefully. The two nitrogen have a single bond between them. So remove that bond and keep one oxygen in this way and make the dots on that oxygen. This is the structure for N2O5. So in this way, how easily we can learn the structure, that is NO2, N2O3, N2O4 and N2O5. So in this way, you can get the structure, you can learn the structure very easily. So once again, try this. Start with NO2, the Lewis structure for NO2. Make one more structure of NO2 in the reverse order. Keep the bond between them. Now it is N2O4. Remove one of the oxygen. Keep two dots. Now it is N2O3. So when you keep one that oxygen, that is N2O4. From N2O4, how we make N2O5? That is, remove the bond between the two nitrogen, keep one oxygen between them and keep the lone pairs on that oxygen. So all of you try these structures in this way. So very easily you can make the structure for NO2, N2O3, N2O4 and N2O5. So here we discuss the reactivity of a group 15 element with oxygen, and we discuss the some of the oxides of nitrogen, its oxidation state, and also we have discussed the structure of oxides of nitrogen. So this is all about this video. Have a nice day.